Hello everyone and welcome back to Diragu Games. I had a lot of fun making this video and I hope that you'll enjoy it and that it will also be useful to you. In this video, we're going to be using an Area 2D node to create a projectile scene for our enemy. The projectile will move in a constant direction at a constant speed. We will also use another Area 2D node to create our enemy and have the enemy spawn bullets in various patterns. We are going to create these patterns by being able to change the number of spawn points that the enemy has and also rotating the spawn points and changing the direction of the rotation. So let's jump in. First, let's make the projectile. All we are going to do is have an Area 2D node move to the right at a constant speed. Really simple stuff, right? We create a new 2D scene and add an Area 2D node to it and rename it to projectile. Next, we add a sprite 2D node to hold the bullet sprite. Then we drag the bullet sprite into the texture field in the inspector. I have a simple diamond sprite. I will adjust its size and rotation to face the right since we'll make the bullet fly off to the right in code. See that yellow triangle with the exclamation point? It gives you valuable information, so don't ignore them when you're just starting out. It says we also need to add a collision shape 2D node because it's a requirement of the Area 2D node. So let's add that. Then, we click the shape drop-down in the inspector and choose a shape and adjust it using the pink handles. I am also going to rotate it 90 degrees to match the sprite. This color screams placeholder, so let's mellow it down by changing it to a mellow yellow. We do this by selecting the sprite 2D node and going to visibility in the inspector and changing the modulate color to yellow. Okay, that still screams placeholder, but in a much cooler way. Now we add a timer node. We will use this to determine how long the bullet will remain in the game, kinda like its lifetime. Let's not forget to save the scene, and while we're at it, we could do a little housekeeping. We can save the scene as enemy projectile and also rename the root Area 2D node to enemy projectile. Nice. Let's add a script by clicking the add script button and save the script as enemy projectile. Now all we need to do is click on the script tab and add a few lines of code. We will need a variable for speed and set it to something like 3000 and add @export to make it visible in the inspector. In the physics process delta function, we set the position of the node plus equals transform.x multiplied by the speed variable we just created multiplied by delta. This will move the node to the right along the x-axis. We need to connect the timer to the script using Godot signals. Let's rename the timer node to lifetime timer. And in the inspector, we click on the node tab. On the timer, select timeout and click the connect button on the bottom right of the inspector. In the pop-up menu that appears, we leave the enemy projectile selected and clicked connect. This automatically adds an on-lifetime timer timeout function to our script. All we need to do now is call queueFree in this function. This will remove the projectile from the scene when the timer time has passed. Back in the inspector, we click auto start and set the wait time to something like 1.5 seconds. Now, we can test the scene by clicking the play current scene button. But first, let's move the position of the projectile and reduce its speed to 1000 in the inspector so we can see this in action. Then, we reset the position back to 0. And that's it. We just set up the enemy projectile. Now it's on to creating the enemy. We'll set up the enemy in a similar way. Click on Scene and then New Scene to create a new scene for the enemy. Then we click on Other Node and add an Area 2D node and rename it to Enemy. Wait a second. Here I am going on and on about an Area 2D node, and I didn't even explain why we're using it. Here's the thing. This video is a part of a series of videos where I'm making a bullet hell game. And I'm using an Area 2D node because it's perfect for detecting collisions. You can check out those videos when we're done here. There's a link to them in the description and also at the end of this video. Okay, now that you're up to speed, let's continue. Next, we will add a Sprite 2D node. I will add this star sprite that I have here by dragging it into the texture field in the inspector and changing its scale to make it fit on the screen. Again, we must pay attention to the yellow triangle and add a collision shape 2D node. In the inspector, add a shape and use the pink handles to adjust its size. Next, we add a timer node and rename it to shoot timer. And the last thing that we'll need is a node 2D and rename it to rotator. We will use this to create the spawn points for the enemy projectile. Now all that's left to do is select the enemy root node and add a script to it by clicking the Add Script button. At this point, we might as well connect the timer to the script using Godot signals again. With the shoot timer selected, we click on the node tab in the inspector and select the timeout under the timer. Then, click Connect at the bottom right of the inspector. In the pop-up window with the enemy selected, we click Connect. We see that an onShootTimer timeout function is created in the script. Now let's take a look at this code. Don't worry, it's easier than it looks, and I'll walk you through it step by step. First, we need to set up some variables, and we will use @export to make the ones we need to change to control the bullet patterns visible in the inspector. We will use these variables here to handle instantiating the bullets. We will need a constant called bullet scene to hold the preload enemy projectile scene that will be instantiating, and also variables for time between shots, which will be the time between firing each shot, spawn point count, which will be the number of spawn points for the bullets, and a radius, which will be the radius of the circle that is created to hold the spawn points. We will use these variables here to rotate the rotator. We will need a rotate speed to control the speed of rotation, a direction change interval, which will be the time that passes before the rotator changes direction, a rotation direction equal to 1, which we will use to determine if the rotator turns clockwise or anti-clockwise, and a direction change timer, which we will use to track the time that has passed between the rotation direction change. The shot timer and rotator variables we set at onReady to be used when the enemy scene starts playing. Let's have a look at these variables in Godot. We can simply drag the enemy projectile scene into the preload, and the location will be populated. However, it's important to note that if the enemy projectile is moved in the file system to a new location, its location is not updated in the script, and this will cause errors. So you will need to manually update its location if necessary. Then, we can just drag the shoot timer and rotator into the script as well. Now in the ready function, we basically run a for loop. It says for the integer I in the range of spawn points, we add a new node at the spawn point position. We are going to use radians to calculate the positions of the points instead of degrees, because it's an easier way to determine the positions of the points on the circle. Okay, let me explain. If we draw a circle around the enemy with a radius of r equal to 100, and we draw a line from the center of the circle to a point on its circumference, then we travel a distance of r equal to 100 on the circumference of this circle. Then we draw another line at the endpoint of this arc to the center of the circle. The angle that is formed at the center is 1 radian. Now since the circumference of a circle is 2 multiplied by pi multiplied by radius, and there are 360 degrees in a circle, it's safe to say that 360 degrees equals 2 pi radians. To get the angle of the rotation between the 2 points on the circumference, we just multiply I by 2 times pi divided by the spawn point count. To calculate the position, we can set it to a vector 2, where the x position will be equal to the radius multiplied by the cosine of the angle, and the y position will be the radius multiplied by the sine of the angle. We can set the spawn point position equal to the position that we just calculated, and the rotation equal to the position dot angle. Dot angle is a method of the vector 2 class that calculates the angle of a vector in radians, and returns the angle between the positive x-axis and the vector. Then we add the new nodes as a child of the rotator at the spawn points created. Then we set the shoot timer wait time equal to the time between shots and start the timer. With that done, we can go to the onShoot timer timeout function and instantiate the bullets. We basically make another for loop to get the children nodes on the rotator. Then set a variable bullet equal to an instantiated instance of the bullet scene. Then get the parent and add the bullet as a child of it at the global position and rotation of the positions that were created in the rotator. And now on to the rotation. I could have just set up another timer node to handle this, but I decided to make a manual timer in the physics process delta function. What do you think? Would it be better to use a timer node? Let me know in the comments how you would handle this. I start a timer counting up with direction change timer plus equals delta. Then, if the direction change timer is greater than or equal to the direction change interval, I reset the timer and multiply the rotation direction by -1. By multiplying by -1, I change the direction of the rotation. To make the rotator rotate, I set a variable new rotation equal rotator.rotation degrees plus rotation speed multiplied by the rotation direction multiplied by delta. Then I set the rotator.rotation degrees equal to fmod, new rotation and 360. Using fmod is just a precaution so that the rotation does not go into a negative or over 360 degrees. And that's it. When we play the scene, we have an enemy that spawns bullets in a bullet hell pattern. And if you want to change the patterns, all you need to do is change the values in the inspector. Don't forget to check out my other videos. Here's one where I go more in depth on creating bullets that I think will work very well with this system. Thanks for watching, and let's continue to build and explore these worlds one pixel at a time.